Hey everyone, in this video we are going to look at the last part of our trig functions of any angle, and what we're going to try to do is, given one trig function and a quadrant or an angle range, find another trig function or possibly multiple more trig functions based on that particular location and the given first trig function. So for number 8 here, I have sine of theta is 3/5 and theta in quadrant 2, and we want to find tangent of theta. Now I kind of outlined a few hints here for how you can go about it. But the first thing is to locate your quadrant and then also where the sides of your trig function are going to be labeled. So for this one, we'll go ahead and look at quadrant 2. And let me go ahead and draw that in. So I'm just going to sketch real quick here, right? Triangle. So there's some angle, right, that's coming out here. We're thinking of this as theta, right, ending in quadrant 2. And we can use its reference angle, right, which is right in here, connected to the x-axis. So you want to always draw your triangles connected to the x-axis. So we're going to draw it down this way. And what we can do is, if sine of theta is 3/5, sine of the reference angle is also 3/5. So we're going to do opposite over hypotenuse. So this is opposite 3 over hypotenuse 5. All right. Once I got that, I want to label the other sides of the triangle. So maybe do some Pythagorean theorem. If it's a nice one like this, where 3 on a leg, 5 on the hypotenuse will be a 3, 4, 5 triangle. You can do that. But with this one, we do know that the side going to the left will be negative because x's are negative in quadrant 2 and 3. So we want to make sure that side gets labeled as negative. After that, you can find any trig function that you want because you have all three sides of the triangle. So if we're looking for tangent theta, right, we can say tangent theta is going to be this opposite 3 over adjacent negative 4. So 3 over negative 4, or just negative 3/4. And that is basically it. So once you have your location appropriately drawn, your sides labeled, you can find any trig function that you want. We'll go ahead and wrap up with this number 9, and then with at least this type of problem, and then we have one more here at the end, which is kind of looking at reference angle formulas, at least using degrees. So with this next one, we have secant is negative 10/3. Theta is going to be in quadrant 3, and we want to find all 6 trig functions of theta, not just one of them. So we already know one of them, right? Secant is negative 10/3, but we do need the other 5. So let's go ahead and draw our triangle again. All right, so this is going to be some angle that ends in quadrant 3. So I'm just going to go ahead and draw my triangle in quadrant 3 connected to the x-axis. I'm going to go ahead and put theta, all right, bar, reference angle right there connected to the x-axis, and use my secant as hypotenuse over adjacent, right? So secant is reverse of cosine. Cosine's adjacent over hypotenuse, so secant's going to be hypotenuse over adjacent. Hypotenuse is 10, and hypotenuse is always positive, so you'll always use positive number for that. And then adjacent will be 3, in this case negative 3, because we're missing the negative for that one. So 3 with a negative in front for that guy. This is not one of our standard 3, 4, 5 triangles or any of the other ones that we know, so we'll have to use a little bit of Pythagorean theorem on this one. So I'm going to say our y squared, right? So we want kind of the y value for that vertical side over there, plus this negative 3 squared is 10 squared. And go ahead and solve that. So I got y squared plus 9 is 100. We'll go and subtract the 9, so we got y squared is 91. And then take our root. So y is going to be either the positive or negative square root of 91. Now, which one of those you pick depends on which quadrant you're in. So since we're in quadrant 3, this y value is going to be negative. So we're going to use that negative value right there and put in negative square root of 91. Once I got that drawn, then I can find all 6 of my trig functions. So I'm just going to label them all out here. We got sine, cosine, tangent. We got cosecant. I'm going to go in order, right? Same order, reciprocals for those. So cosecant, secant, and cotangent. And even though I know, right, secant, I'm just going to go through these in order. So sine, this is going to be opposite over hypotenuse. So this negative root 91 over 10. So we'll go and put it negative root 91 over 10. Root 91 is not going to simplify. So if this were, say, like square root of 49, I would simplify that to like a 7. But anything that doesn't simplify down, you can just leave that. Cosine, this is going to be adjacent over hypotenuse, so negative 3 over 10. Tangent, opposite over adjacent, so opposite root 91 over the 3. Negatives will cancel out, so we're going to get positive root 91 over 3. Cosecant, we'll just flip the sign, so this is now negative 10 over root 91. Again here, I'm not going to rationalize, I'll just leave it like that. Secant is going to be negative 10 thirds. And cotangent is going to be 3 over root 91. We got 3 over root 91. So that is all 6 trig functions. A lot of times they will ask for just one of them. Like if you have secant, find sine, or if you have secant, find cotangent, something like that. But every now and then you may come across one where given one trig function, you want to find a whole bunch of other ones. All right, our last question that we'll go through is related to reference angles. And remember, reference angles are just going to connect to the x-axis, whichever way is closest, either the positive side or the negative side, and will always be positive. So we have an angle A somewhere between 0 and 360, and we want to know what formula we could use to find A bar, the reference angle of A. So it is important to note, right, A is between 0 and 360, right, not some huge angle, up in the thousands, not some negative angle, but somewhere between the 0 and the 360. And we're going to go ahead and just draw these out, see what we think it's going to be. All right, so if I'm going from 0, right here, up to some terminal side in quadrant 1, right, this would be my angle A that I've traveled around so far, and the reference angle A bar will be exactly the same, right? So this A bar is going to be exactly the same as A if we're in quadrant 1. So if you're between 0 and 360, quadrant 1, reference angles are actually the angle, same thing. If we go around to quadrant 2, I'm going to go ahead and kind of highlight that angle. So around here to quadrant 2, we're going to say terminal side right there. Reference angle will be this guy right here, A bar. How would that relate to that other angle? So if that red angle is A, I'm just short of the 180 degrees, right? 180 degrees is over here. So if I went the full halfway around, I'd be at 180, but I'm a little bit short of that. So we could take just the whole half circle 180 minus that original red angle A. And so I'm going to say this is going to be 180, right, minus A. That gives us the leftover A bar that we are just short getting to the 180. If our angle were in quadrant 3, right, so if our angle went all the way around, right, say to here, quadrant 3, let's go ahead and put in terminal side, let's say somewhere there. Now this is my A bar right here, my reference angle for A. Then we've gone past 180, right, exactly that reference angle. So we went 180 and then past it exactly that reference angle. So if I want to find a bar, I would just need to take that huge angle, right, the red angle that I went all the way around, and then just take out the top half, right, subtract the 180. So this is going to be basically reverse of quadrant 2. So A minus 180. And a lot of these, rather than, I would say, memorizing the formulas, if you can just draw it out, it will save, just as much time as having to memorize the formulas a lot of times. So drawing out is also a good approach if you don't want to have these formulas written down somewhere and can just do it from the drawing. All right, last one, quadrant 4. We're going to keep going, right? So around quadrant 3 into quadrant 4. Terminal side will be somewhere over here, right? So we're going to say, let's say somewhere right there, extend that a little bit. And our reference angle will be right there in between the x-axis and that terminal side. So this is now our A bar. So in quadrant 4, we've gone, right, almost the whole 360. We're just a little bit short. So this is going to be very much like quadrant 2, where we're short of part of a circle. So we're short of the 360 all the way around by that A bar. So we'll just take our 360, right, all the way around, subtract our angle A, and be left with that little gap that's in between. So that would be the formula that you could use to find the reference angle if your angle is between 0 and 360 and you are in quadrant 4. We're going to see some similar ideas and formulas when we get to radians. That will be after the first exam, so those will be coming up later in another video, but the same ideas can be applied, right? Half a circle, whole circle, but add or subtract that angle A that's in there. Usually subtracting A or sometimes subtracting from A if you're in quadrant 3. All right, that will do it. This will be the last one for those trig functions of any angle. Again, most of the ideas in here are related to just identifying where angles lie, the different quadrants, reference angles, and then sines and cosines, all the trig functions of reference angles being the same as the angle, except for maybe a plus or minus. And if you take a trig function of coterminal angles, angles that end on the exact same ray going out from the origin, those will always have the same trig values. So that'll do it. That'll give us a way of dealing with larger angles, especially when we get to the law of sines. There's going to be triangles that we see that may be something like this, right? So this might be our triangle. And this angle is going to be bigger than 90, right? So when angles are larger than 90, we need a way to find those sines, cosines, and things like that. It's going to be kind of a pain for law of sines. There's something called an ambiguous case, which is not ideal, but we'll talk about that in a separate video. So that'll do it for this one, and we'll see you on the next one.